So the furler assembly came back from bead blasting and machining. As you can see, here's the area where the castle nut was grinding through the casting at the bottom. What the machinists have done is they've fashioned some Delrin bushings. There's going to be not quite an interference fit, but very, very tight. This is the stuff that we're gonna reassemble. I've got my new 1.8 horsepower fully sealed motor. That's probably the most important part, I suppose. I mean, everything here down to the smallest little item is important and irreplaceable. So, however, I want to call your attention to this. These were the set screws and what's left of them that were down inside the furler assembly. Those went into these two holes in this gear. As a result, the gear could slide up and down the shaft, and occasionally engaged and other times didn't, and you can probably see the wear on the faces of the gear. Of course, there's really not much that we can do. I think a lot of that wear is from grinding these pieces of metal up, and so, you know, we haven't lost any teeth or anything, but I have a feeling that that everything's not ever going to be perfect in the end. But, you know, it's going to be better than it was. We're going to replace all of these gears along with the races that go with them, and of course we've got our rectangular shear pins here, which were also kind of threatening to fall out, but they couldn't because there just wasn't enough room for them to come out. So the whole thing didn't just spin. You can imagine with these being out, with this not functioning properly, with not enough automatic transmission fluid in the system, and a completely spent motor, that this furler was not working optimally. My next kind of challenge is to get this race out. You may or may not be able to see the damage to the race in there, places where there's high and low marks in there, but it's been pretty badly abused. There's another one up top that we took out that was really, really bad, and that one's you know, long gone. You know, at this point I've replaced this race and this race. I was unable to get this race out. Actually, this is a new race. I was unable to get this one out. It feels like the bearing spins well enough on it that I'm not gonna go crazy about it. I'd rather not do damage to the casting or anything like that. So now it's going to be time to read the directions again one more time and make sure that I've got this all done in the proper order. So one of the more important parts of dealing with seals is making sure that you've lubricated them. Different seals handle different products, different lubricants in different ways. It's important that you not use the wrong lubricant for a seal, and that oftentimes means that that you're really not sure what the seal's made of. If you know, there's different types of rubber compounds being used. The general way it's done, people in the trade say, is lubricate the seal with whatever lubricant it's going to live in. So in this case, it's automatic transmission fluid. In a car, it might be motor oil. So we're using a little bit of genuine Myanmar ATF. That's what we happen to have, and we're going to lubricate these seals now. These guys are going to paint this later. This is all going to have to be cleaned and re-lubricated, and in fact, I'm kind of thinking I'm just going to use enough of the ATF in order to help seat the seal. I don't want dirt to be attracted to this seal. Let's talk a little bit about what's happened with this and why I got stopped dead in my tracks. This has been kind of the never-ending project for me. this furler rebuild. And what ended up happening was this. I should have checked this earlier when we disassembled it. But what ended up happening was, as you can probably see in the reflection of the light, there is a lot of damage to the bearing surfaces here. There's also these tabs have opened up, and there's actually a hairline crack in one of them. This is what the part is supposed to look like. We had to have this one machined, and it's from formula, from the people that made the original part, and this is the motor drive. What was happening was what they call the grub screws. These little screws here had fallen out of this gear and gotten down inside the assembly and was periodically locking up the assembly while it was trying to be used. And when that happened, it would put a tremendous amount of force on all these parts. Now this gear is not perfect, but it is wear mated to the other parts in there. And the guys at Formula said, you know, if it's working and there aren't teeth broken off of it, you know, you'll probably be okay with that. They do have these. They're very, very expensive to buy. But I'm going to go with what's here. He says the new ones will run very noisy for a time until they break in, and he says it actually takes a very long time for them to seat, and it may do damage to the other gears if you try to put a new one in there that's not wear mated to it. So we're going to go with this, and we're going to Loctite the grub screws in place. We also got a new carrier. This is called a carrier, and the bearings go in here. And unfortunately, the old carrier, they sold me the new bearings, but then once I started talking to the guy, he goes, "Oh yeah, you know, they're virtually impossible to get out. You know, to get the old ones out of the carrier is a very difficult thing to do." So we are going to make sure that we get this whole thing put back together the way it's supposed to be, and then we'll be good to go. Man, I'm telling you, getting these bearings in is not something that I don't know how you would ever get them out. That's all I can say. And they recommend using a bearing press, but I don't have one. But I do have a big ass vise, and I'm using that to just shove them. Good. Yeah, so the problem I'm running into with this is that it's not seating properly. I don't quite know why. I'm having trouble figuring out why it wouldn't seat properly. I guess I'll just kind of play around with it some and see if I can maybe see how the older one works. I'm having the one part I didn't bring over here was these thrust washers, the old thrust washers. I didn't imagine that there would be an issue with that, but it's looking to me like something along the way isn't quite the same, whether it's the motor or what, I don't know. So here Wendy came to help me out with this thing, and I mean, I brought all of the old stuff with me except for these two thrust washers, right, that they gave me new ones of. The new ones are thicker than the old ones, and the whole thing won't assemble properly with the new washers. Luckily, the old washers are in good enough shape that I can reuse. But it's just I'll even show what the issue is here. So here, this is with the old ones. See how it fits flush there. Hey, I'll just hold that for a second. And then, if I flip this out, put the new washers in.
The ones they sent you.
The ones they sent me. And I put it together. And look what happens. Now, you've got this ridge. It sits proud, it sits high, and because of that difference, the motor won't bolt on. Just that little amount of space. This has been tightened on here with Loctite, blue Loctite, per the people at Formula, and I think we're in pretty good shape to continue on. Once I drive the pin through the kind of roll pin through this hole and in through the main shaft, getting this back apart is not going to be easy. And so really want to make sure I've got this thing, you know, totally good to go, that there's going to be no problems later on. That's that. Everything back together. Well, so here's our mostly assembled furler, and this is an example of how motor technology has changed since this boat was built. You can get much more powerful motors. A big design compromise here is that this motor has to fit inside the mast section, and so it's, by definition, it has to be relatively small. And you know, this was a very expensive repair. 1,500 pounds, not including the motor, the seals, the new parts inside the assembly. But it's all put back together now and ready to go. This is the machine work. This was probably the largest part of the repair. Was, let me see if I can find this link. This is the gooseneck link, and what the machinists have done is they've bored out this hole and put a sleeve. They call it machine plastic, but I believe it's probably Delrin or a similar generic version of Delrin plastic. And so it's designed to take up the slack and to provide a surface, a self-lubricating surface that takes a tremendous amount of force going through it. And so here's the hole, kind of the area that was eaten away by the castle nut on the bottom of this, because this lower piece was so, this lower link, this lower hole was so loose that the whole nut was being pushed into the casting. So it's an interference fit. It's very, very hard to get this pin through. They tell me it'll loosen up once it's in place, and I agree that it will. But in the meantime, it's going to be tough to get this all together. I think we're good.
Do you want it up higher, or?
Yeah, we're gonna need to. Well, we can't really say it's an ideal day for going up the mast. Right? Say hi, Doug. We're filming. Doug's our neighbor. He's gonna help us with this.
Kevin's about to do his hero bit.
One of my more hated tasks.
Yes.
But it's, of course, has to be, at least it's sunny, but it is blowing like 25, 20, gusting to 25, we've seen.
Yeah. A long way up.
Here we're just kind of chasing the threads a little bit, just to get the corrosion out. The previous, screws were in here for a long time. We've got some paint in here, as long as just general, the kind of white crustiness that forms between stainless steel fasteners and aluminum. And we want to get that out because we don't want these screws to be, impossible to remove later. One of the problems we found when we disassembled this was the original sheaves were really worn. The plastic was kind of ob-rounded around the pin. There were chips in the plastic. It was plastic had faded. Probably the plastic technologies back in the day weren't nearly as good as what they are today. So I've reassembled these. They have cotter rings on them, and they will have cotter rings in the end as well. But the cotter rings are very easy to take off and on, and so therefore we're going to be able to remove these in order to get the lines through. The lines are going to need to. They're not going to fit through with the sheaves in place, but nonetheless, it gives us the location of the spacer, the separator plate, and that's what we want to see. So this coating on here is called Jota coat, and the guys at the machine shop say that it's awesome and unbelievable. It sticks to aluminum. You don't have to worry about cleaning the aluminum particularly, although they did clean it quite a bit with brake cleaner and some other. They actually ultrasounded the parts as well to get them clean prior to coating. We've got Tef gel in all the chase threads. Just on this side, we'll put some on the bolts as well to make sure that there's plenty of Tef gel in between the stainless and the aluminum casting, so that if we ever have to get this apart, it won't be, completely impossible. Here I've also gotten some washers to separate these. Now, unfortunately, I don't have plastic washers. Plastic would have been preferable because the stainless steel washers will be up against the aluminum, but they should be loose and kind of rolling around, so I don't think there should be a problem. We're going to throw some Tef gel on those as well, just to kind of create a film over top of the stainless. It won't last very long, but that'll have to be what we use. There's no other option. They don't sell plastic washers, and the manufacturer Hood formula doesn't have them anymore. Gonna go in the holes, okay? That's right. Yeah, it's one over here, so. Well, so there we are. Yeah, well, my crew left me in a huff because I keep wanting to do things exactly one particular way, and she's not happy about that. So guess what today is? New sail day.
And what is it we're doing here?
Check in our new sails. We're going to start by making sure our shackle is tight. Going to get a little seizing wire.